Hello, algebra. Last but not least, part 3 of functions, we're going to talk about what are called inverse functions, right? So you've talked about inverse operations like addition and subtraction, multiplication, division, squaring, and square roots. So that stuff's going to apply today, but there's an idea behind inverse functions. So let's talk about what inverse functions are. So if we have a function f of x, right? So for that function f of x, you have a bunch of ordered pairs x and y, and you have a domain of f, and you have a range of f, right? The domain are the collection of x's, the range is a collection of y's. Well, we're going to talk about inverse functions. Here's our notation: f inverse x. So when you put this -1 exponent, that word is inverse. When you do geometry next year, you're going to talk about inverse trigonometry: inverse sine, inverse cosine, inverse tangent. Now what happens with an inverse is that instead of your points being x comma y, now your points are y comma x. Your x and y switch places. And if your x and y switch places in your ordered pairs, that means your domain and range switch places. So the domain of f inverse is actually the range of f, and the range of f inverse is actually the domain of f. So it's a bunch of switching places. That's all it is. So we're going to do a definition using a table of values and a graph, and then we're going to find an inverse function and then solve a word problem. All right, inverse functions. And we're going to stick just to linear functions today, by the way. So you're welcome. Again, if you take Algebra 2, you'll get into much more fun inverse topics. So it says find the inverse of the relation shown, graph the given relation and its inverse. So this is your function. This is f of x, and I'm going to use red dots for it. Okay? So I'm going to go ahead and graph this, right? So -5, 1, 2, 3, 4, 5, -4, -1, 1, -1, 1, sorry, -1, 1, that goes up 1, 1, 2, and then 2, 3. Sure. Okay, so there are our f of x points. So now I want to create a table of values for f inverse of x using blue dots, right? Well, for f inverse of x, your xy table is going to look very similar to f of x, but the numbers switch places. So now your point is -4, -5, 1, -1, 2, 1, and 3, 2. So there is your table of values for f inverse. We're going to graph that: -4, -5, 1, -1, 2, 1, and 3, 2. Okay? And I wonder if you can see, right? Do you see how I could draw a diagonal line through the middle between those points, right? If you were to connect those points, if you see this, right? 0, 0, 1, 1, 2, 2, 3, 3, -1, -1, right? This dotted line is the equation y equals x, because every point on this line has the same x and y value. So like this point right here is 4, 4, right? So y and x are equal. When you are graphing a function and its inverse, they are reflections of each other across the line y equals x. So that is an important concept to understand. So f of x and f inverse of x are reflections across the line y equals x. So visually, right, if you see two functions being graphed, if you can draw that line in between them, y equals x, and it looks like they're flipped versions of each other, then you know that they are inverses. Okay, number 2. So it says the following function is 1 to 1. Find the inverse of the function and graph the function and its inverse on the same set of axes. So let's first find the inverse. So let's take a look what we're going to do. So very first thing we're going to do is cross off f of x, put y. Okay, so number one, just like our table of values say, we're going to swap x and y. So I'm going to do that. I'm going to skip. I'm going to do it right here. So we're going to swap x and y. So that means instead of saying y equals, it'll say x equals 1/4. Instead of saying x, it'll say y minus 1. And now we're going to use our skills from topic 1 to solve for y. Make this now say y equals. Okay? So there's a couple things we can do. You could try to go ahead and get rid of that 4 because it's a denominator. You'd have to multiply everything by 4, but I'm not going to. I'm going to get rid of this 1 first. I'm going to focus on this 1 over here with the x. So let's do this second step in blue. Sorry. So let's add 1 to both sides. So this is x plus 1 equals 1/4 y. And now let's multiply by this reciprocal of 1/4. The reciprocal of 1/4 is 4 over 1, or just 4. And you have to do it to everything. The x, the 1, and the 1/4 y. So this becomes 4x plus 4. And over here, the 4 and the 1/4 cancel, and you get y. And there we go. Now, we're going to replace y with f inverse of x. So f inverse of x equals 4x plus 4. And this is our inverse function. So now we're going to graph these two functions on the coordinate plane using our topic 2 skills, right? So we know this is slope-intercept form, y equals mx plus b. So our b value here is -1, so we're going to start down 1. Our m value here is a positive 1/4, which means up 1 and to the right 4. Up 1, right 4. I'll do it one more time. Up 1, not there. Sorry. Up 1, right 4. There we go. And this is going to be our function f of x. I'll go down 1, left 4 as well, just to get another point. There we go. So there's f of x. And now in blue, I'm going to graph f inverse of x. So again, your b value is a 4, the second 4. So we'll go up 1, 2, 3, 4. And then our slope is 4. So that is a positive 4 over 1, which means up 4 and right 1. So we'll go up 4, right 1. I can't do it again, so now from here I'm going to go down 4, left 1. I'll do it one more time. Down 4, left 1. Good, and I'll graph that as best I can. And there's f inverse of x. And there's your two graphs, right? And now again, just to kind of show you, and see they cross. So just try to show you, I'm going to graph the line y equals x going through them. So again, that's 0, 0, 1, 1, 2, 2, 3, 3, -1, -1, -2, -2, right? And that should be the line of reflection for these two graphs, right? Y equals x. And again, if you notice here, notice they cross at this point right here, right? That is the point -1, -1. So if you were to swap that, it would still remain -1, -1. So that's why it's on both points. And if we focus on these 2 points right here, right? This red graph has a x-intercept at 4, 0. This blue graph has a y-intercept at 0, 4. And that should happen, right? Your x and y-intercepts should swap places because you're swapping the x and y coordinates. And there you go. So again, a good review of solving for y, a good review of graphing lines, things that your Algebra 2 teachers are going to expect you to be able to do. Okay, last but not least, example 3. So it says if a salesperson works for $173 per week plus 10% commissions on sales, his weekly salary is this, where y represents the salary and x represents the sales. Find the inverse function and use it to find the sales for a week in which the salesperson's salary was $876.40. So they give us two things. They give us the formula. So y equals 0.10x, so that's the 10% times the sales. So when you make commission, if you sell a TV, say for $1,000, 10% of $1,000 is $100. So you make $100 off that sell. That's why sometimes when you go to stores, like if you go to a furniture store, or like I said, electronics store like a Best Buy, people will approach you because they're trying to get your sales, commission off your sales. And then they get $173 just for showing up, right? That's like their total hourly wage, okay? And then they give us this number. Well, this number is the salary. It's the y value. Typically, we're given an x value to plug in and then simplify and get our y. Well, this time they gave us a y. So you could solve this problem by plugging that in for y and then solving for x, or you can do what they're asking you to do, and that is find the inverse first. And that's what we're going to do. So the first step in finding the inverse, swap the x and y. X equals 0.1y plus 173x. Step 2. Now make it say y equals. To do that, we're going to subtract the 173. Again, subtract the thing without the y first. So we're going to do x minus 173 equals 0.10y. And now I'm going to divide by 0.10, and I'm going to do it to all three things. So there's actually a 1 up here. When you divide 1 by 0.10, you actually get 10. So this is 10x. Minus 1730 is going to equal y. And this is our inverse function. F inverse of x equals 10x minus 1730y. And again, what this function represents is x equals your salary, and y, or F inverse, equals your sales. So say you wanted to find out how much you would have to sell in order to make a certain salary, this is the formula you would use. So now we're going to take this 10x minus 1730, and we're going to replace that in for x. I know it says y, but now we're going to place it into the inverse, where x is now our salary. So now this is an x value for our inverse function. So I'm going to do right here 10 times 876.40 minus 1730. And when I multiply that out using Desmos, I'm going to get $7,034 in sales. And again, that is a way that you can use an inverse function to plug in a given y into the inverse function to get out an x. All right. Good deal. Okay, all right, good luck on this practice.